Okay, guys, welcome back to another lesson. Okay, we're moving on from 3D shapes to, well, more 3D shapes technically, a little bit. We're going to talk about parallel lines and transversals. Okay, so another whole set of angles are going to come into place, which is pretty exciting to be honest with you. It gives you more of an opportunity to see some other things that geometry has to offer here. Okay, so here we go. Starting off, the one question I ask is this guy truly a giant, a larger human being than this poor woman here in the corner standing next to him? Okay, this is an optical illusion, and probably something that you've seen before. This room is not entirely parallel; it's not symmetrical in any way. Okay, in fact, this is called the Ames room. Okay, which exhibits this optical illusion. If you look at this from a different perspective, you can see that, oh, wait a minute, the floor is actually slanted a little bit, okay? And it's creating the illusion that this guy here in the corner is like 10 times smaller than the other guy here. So looking at it from a perspective, this person is actually viewing this guy closer to his eyes than this guy is, given that appearance that the guy's a lot larger, okay? If you watched like Lord of the Rings, you know how the hobbits are a lot smaller than Gandalf. Okay, they use a very similar technique when it comes to making that work. Okay, they actually mess around with the lenses of the camera, and they actually film the scene two different ways to create that illusion that Gandalf is a lot taller than all the hobbits around him. Okay. So let's talk about some definitions here. Okay, we have parallel lines. They're coplanar lines that don't intersect. The abbreviation is this double bar. Okay, so for instance, we could say that line A is parallel to line B. So that's what that would say. So line A is parallel to line B. Okay. Visually, we show it by using those arrows over there. So if these two lines truly are parallel, we'll put arrows to indicate that. Okay, that's what those mean. All right. Skew lines, they don't intersect and they're not coplanar. Okay, so they're in different spaces entirely. So think of it this way: skew lines are not going to be parallel. Okay, so that's one way to differentiate between the two. And then parallel planes, okay, that's where you have two planes that don't intersect. So there's two different cases there. Think of it as just pieces of paper, right? These would be parallel planes. Vertically, right? Diagonally, any sort of angle, as long as they don't cross each other. Okay? So here's an example. We're going to identify all the segments that are parallel and skew depending on the question that we're being asked here. Okay? So I'll tell you what. Let's get a better color, something a little bit darker so you can see this. Okay? Look at the first problem here. And actually, hold on. What shape is this guy? We just talked a lot about 3D shapes. That would be a what? A triangular prism, right? So just a quick recap. Identify, okay, all the segments that are parallel to JP. So here's JP. So we want segments that are parallel to it. Okay, it's not going to be this guy here because it's intersecting with this one. Okay, these two would be out because they're both intersecting. Okay. Parallel, if you remember back from algebra, they have the same slopes. Okay, so we're looking for the almost identical line. So keeping that as our guiding point, we could see that JP and LR would be parallel to each other. So LR is one of those line segments. And if we take a look over here, JP would also be parallel to KQ. And the other key part here is that they're coplanar, right? JP and KQ are part of this rectangular plane. LR and JP are part of this rectangular plane. Okay. Next, three segments that are skew to KL. Okay. Now, skew doesn't mean intersection, though. Okay, they're not going to intersect. They're not in the same plane. So there's a lot in this picture, I think. Oh, let's see. I'm going to say that JP would be one of them. Okay. JP is not in the same plane as KL, right? and they don't intersect. They're not parallel, that's the other key part. We could also do PR, which would be another skew segment, okay, with the same reasons, right? PR doesn't intersect here. It's not the same plane, and it's not parallel. And we could do PQ. We can go the other direction for the same reasons. Okay, so skew is always like a tricky one for people to remember. So think of it this way. No, just nice little checklist. They don't intersect, not coplanar, not parallel. Okay, those are the three things you're looking for. And the last one, a plane parallel to PQR, that's the bottom of it. So that's would be what? Triangle JKL. That would be parallel to the sky. The top part of the prism, right? The bottom part, top part, they will be parallel to each other. Okay? All right, let's try another example here. Same premise, so we'll just draw a line here. Identify all segments parallel to BC. Now, I am going to include segments that aren't coplanar because we could say with some confidence that they are still going to be parallel. So I don't want you to say, well, Mr. McCullough, they're not coplanar, so they can't be parallel. We can make arguments that they still are, okay, that they appear to be parallel. I should put appear to be parallel as well, okay? Sometimes you'll see that on different assignments where they will use that wordage to help with the coplanar part of that definition. So let's see. Here's BC, okay? So I can say AD is parallel to it, right? FG, which is across from it, is, and HE. Since HE is parallel to AD, it has to be parallel to BC. Almost like a transitive property in a way. Let me write these segments down. So AG, FG, AD. Doesn't matter the order, right? Line segments, you could switch the points, means the same thing. Okay, two segments that are skewed to EH. There's a bunch of them in here. DC would fit the bill. We could do AB since that's the other one that's next to it. Let's add some more just to have more of a reference here. Let's say FC would be skew. Is that G? Yeah, GB. Okay. Next one, name a plane parallel to FCB. Okay, so F, C, and B. That's the bottom plane. So the one that's parallel is the top plane. It's that rectangle, right? So we can call that, what, rectangle or plane H, E, D, and A. Doesn't matter the order. Don't skip around points. Remember, whatever letter you start with, go clockwise or counterclockwise when naming it. You want them to be consecutive. Notice how this one didn't name the full plane. It forgot G, right? One thing, just to kind of point out, a plane only needs 3 non-collinear points, so you really don't need to list all 4. However, what I would do is, since you have all 4 there, it's not much work to put that 4th letter in, okay? But if you don't, that's fine. Remember, it only requires 3. Okay, so now let's talk about transversals. So we're going to make a shift. So we talked about 3D shapes, what's parallel, what's skew, and same thing with planes, what's parallel in terms of that. Now we're going to talk about transversals. It's a line that intersects 2 or more coplanar lines at two different points. So here's a transversal line here. Matches the definition. It's intersecting 2 lines at different points. Over here is 4 lines, but once again, the transversal is cutting through all 4 lines, right? It says it could be 2 or more. Okay. Now, one thing I want you to be cautious with, the lines don't have to be parallel. Now, you notice how these guys are parallel, okay? Or appear to be parallel, we could say. So it doesn't have to look that way. What do I mean by that? Well, you're going to see this in the next example, but I'll talk about it real quick. I could have planes. I could have lines that look like this, okay? Or, actually, you're going to see this exact example, okay? So notice how, make this one green. This green line is a transversal line. It cuts through 2 other lines at 2 different points. So this is a transversal line. So this is another good example, okay, that doesn't show parallel lines. That could also happen. Now, if you notice, when I do make that intersection, I have all these angles that are formed. Now, we know what some of these are already. These guys would be linear, right? These would be a set of linear angles, okay? These guys across from each other, these would be vertical angles. So some of these already should be familiar, okay? So look at this figure. Can we identify the transversal lines? Ignoring the numbers. Don't worry about the numbers yet. That's just the angles. I named one of them, right? This is a transversal because it cuts through two other lines. So that'd be line M. That's a transversal. Line L is a transversal because it does the same thing, right? Intersects at two spots. And then line N is a transversal for the same reason. So all three lines, L, M, and N, are transversals. Now, let's talk about the angles, okay? So we have interior and exterior angles, and this is in relationship to the two lines that are parallel, okay? Or the two lines that's being intersected. It doesn't have to be parallel. So for instance, the blue rectangles, the blue squares, okay, would be exterior because they're outside of these two lines. The orange ones are interior angles because they're inside the lines, okay? So these are just adjectives. They're just locating what angles we're looking at. Let's try and be a little bit more specific now. Let's look at the interior angles. Now let's talk about locations a little bit further. 4 and 5, those angles, we're going to call them alternate interior angles, okay? The interior part tells me I'm between the lines. Alternate means we're going to the left and to the right of that transversal line, okay? 3 and 6 would be the other set of alternate interior. Same reason, inside the two lines, and they're left and right of the transversal, okay? Alternate exterior angles, same premise. The only difference is that we're outside of the two lines. So that means we have an exterior location. So 7 and 2 are one set of alternate exterior. 1 and 8 would be the other set of alternate exterior. Okay? Just naming locations. That's all we're doing. Okay? We'll talk about measurements in the next lesson. Next, we can have what's called consecutive interior angles. So pick this word apart. Interior means we're inside the two lines. Consecutive is one after the next. And when we do this vertically, or just across, I should say. So look at this. 3 and 5 are across from each other. We consider those consecutive interior. 4 and 6 would be the other set of consecutive interior. Okay? Next, corresponding. Okay, corresponding at first is sometimes difficult for people to locate, but here's the important detail when it comes to corresponding, okay? They are in the same position on both lines. What do I mean by that? Look at 1 and 5. They're both to the left of the transversal, and they're both sitting above their respective lines. So that's corresponding, okay? 2 and 6 are the other set of corresponding angles. They're both to the right of the transversal, and they're sitting above those two lines, okay? So here it says, can you identify 2 more sets of corresponding angles? I think we can. 3 and 7 are one set. They're both to the left, and they're both underneath the line. And then 4 and 8 are both to the right and underneath the line. So, like I said, same location in both sections. If this was like one picture, and this was another picture, okay? We're looking at the same locations. All right. So looking at this guy, a little bit different at first. We're going to try and locate a set of each type of angle. All right, that's our goal. write this down here. So A, alternate exterior. B, alternate, nope. B is what, consecutive interior? I'm going to abbreviate, guys. So don't be alarmed if it doesn't look the same. Corresponding, and this one would be alternate exterior. Okay. One thing I want to note before I move on, consecutive interior is also called same side interior. Okay? You can use either word to describe those types of angles. A lot of people actually prefer same side interior angles because that's more specific. Okay? Same side of the transversal inside the two lines. So you can actually locate this a little bit better if you use that word instead of consecutive. But either way, consecutive means the same thing. It's just one after each other. All right, so let's name a set of each. And we're going to do a couple of them. Alternate exterior. Here's the plan. Look for a transversal, look for two lines, ignore everything else. So here's what I'm going to do. I'm going to ignore this. It's gone. Yeah, I just hit the TV, and I could have probably damaged it if I hit that harder. I got to be careful. So let's look at just this picture, this bottom part of the picture. So alternate exterior angles. So here's my two lines. So I want angles that are on the outside and alternate left and right. So that's going to be what? 7 and 9, 5 and 12. Okay. So angle 5, angle 7, and then I said, oh no wait, angle 5 and 12. Sorry. And what was it? Angle 7 and angle 9. Okay. Now we could change this. Let's ignore this. And we look at this section here. Another set of alternate exterior, we can keep going. I'm just going to name one more. All right. Would be 8 and 1. They're on the outside of these two lines, and they're on opposite sides of the transversal, left and right of it. So we'll put down angle 1 and angle 8. A lot more in there, but that's a good start. Okay, same side or consecutive interior angles. Once again, only look at two lines and one transversal. All right? So we got 6 and 10 are same side interior because, well, they're both on the same side of the line, and they're inside the two lines, right? 8 and 11 would be another one. So let's write that down. 6 and 10, 8 and 11. And you know what? Let's name one more. I'm going to block this section out. So looking at just what's here, another set of same side interior would be 10 and 2. Okay. And we'll stop there. You can keep going. Corresponding, they're the same locations. So let's, and mind you, I'm just randomly picking. Okay, like I'm blocking this out so I can see this set of lines in the transversal, and I'm naming the angles that I'm seeing. Okay, so I want corresponding. They have to be in the same position, right? So look at this guy, 10. 10 is above this line and to the left. So 3 matches it, right? Above this line to the left. So 3 and 10 would be a set of corresponding angles. Can you name some more? Hope you can. How about 9 and 4? They're both to the right and they're beneath the line. So 4 and 9 would be another one. Okay. And the last one, because we were doing 3. Oh, what do we think? How about 11? 11 and 2. To the left and underneath the line. All right. Last one, alternate exterior. So, let's go over to this picture. We'll block this out. We'll look at this part. So alternate exterior would The 5 and 4, they're on the outside of the two lines, and they're going left and right of this transversal. 8 and 1 would be another one. Let's see, angle 5, angle 4, angle 8, angle 1. And, let's block the top. We haven't done that one in a while. I set up alternate exterior for this guy. Let's try 5. No, alternate interior. We did alternate exterior. Oh my gosh. We didn't talk about alternate interior. You should have told me. Why weren't you paying attention? Why weren't you telling me that I did that wrong? Let me change that. Okay. Let's go back to this. I am so sorry, guys. You're going to hate me. Now you have to erase that. Alternate interior. That would be 6 and 3. They're inside and left and right of the transversal. 7 and 2 would be the other set. Inside, alternating, left and right of the transversal. So let's see. 7 and 2. 6 and 3. I was doing alternate exterior again twice. I think I just wrote that. No, I didn't write that in the same angles. Good. That would have been bad. Okay. Now this one, 2 lines, transversal. So that's going to be 2 and 12, 10 and 4. Those would be in my other set over there. And are there more in the picture? Yeah. What did I say? No. 4 and 10 and 2 and 12. Sorry, guys. I'm a mess. I'm an absolute mess today. Okay. So that's it. That's the lesson. So that covers the types of angles. And these are all descriptors. It's just adjectives, locating where these guys are at, depending on the picture, right? And the lines are being intersecting and crossed. We'll talk about measurements later on. Okay, there are some unique properties when it comes to these guys, but for right now, I just need you to know the location and the name. Okay. If you have any questions, please let me know. Other than that, enjoy your day, guys, and I will see you guys in the next lesson.